Hello, everybody. So I hope, because there was a change in schedule, officially the session was supposed to start at 12:45. So I hope everyone that wants to see this is here. Happy to be here, and we will talk about how you can use AI and Gen AI and AI agents in the most critical environments, right? Where trust is key, where complexity is overwhelming, because Gen AI can write a poem for your mother's birthday, no problem, right? But for the most trustworthy enterprises in the world, like Deutsche Bank, it's a different story. Yeah, that's our talk. We were introduced. So you've seen all the examples of in social media of all the funny mistakes AI makes, right? And this is for consumer use cases. This is funny, and it's not really hurting anybody. But you've also seen that large enterprises have disabled or have basically failed with their use of Gen AI. A great example is Apple. They switched off their AI news summary because it was producing a lot of fake news. And there's plenty of examples. And this is a BBC study. In 45% of the time, AI agents misrepresent news content. And this is from an academic paper. You see the reference at the very bottom. This is my favorite quote from that paper. Research shows LLMs are strongly overconfident in wrong solutions, mimicking reasoning, but with nonsensical arguments supporting equally nonsensical answers. Models claim high quality for their solution and are strongly confident that the wrong solution is correct. And of course, when you think about the most complex and critical enterprises like a bank, this is where decisions and wrong decisions can massively impact us all and change the world. So we have to be extra careful. And so here's one of those examples that are basically plucked from social media. This was an agent that was analyzing data, and I've basically summarized this, analyzed the data. These are the findings. And then the user looked at the finding, that doesn't seem right, and then asked, so let me get this straight. You wrote an entire response guessing instead of reading the actual document I uploaded, that I just uploaded. And then the bot answers, you're right to call that out. Here's exactly what happened. Your previously uploaded document is no longer available in this conversation. So I wasn't guessing to be lazy. I literally couldn't access the document. But instead of telling this to the user, the AI agent was making up something that plausibly could have been in the document. And think about the impact this can have. So the gap between confidence and correctness can be super crucial. And basically, all of LLMs are word processors, like next token generations, word processors. But speaking is thinking, and thinking is speaking, right? And so they're mimicking reasoning, and they come to quote-unquote conclusions that lead us astray. And so basically you can ask yourself the question, how do we combat this? Has model size anything to do with that? Do we need larger models? Do we need specialized models? There's this whole new idea around small language models. Model size, from our experience, really does two things. Capacity, right? So what an LLM is basically doing is it's approximating a high-dimensional distribution. And when you want it to learn more, you need a bigger model to do that. So if you want one model that can write a poem for your mother's birthday, but can also run the back office kind of processes of a large bank, you just need a bigger model to do that. But it's also about complexity. And I don't want to go all math nerdy on you, but when you think about the different complexity that the right answer may need. So I'll give you an example. something like, good morning, how are you? That's a very simple opening, super standard. If you want a language model to be able to do that, understand that, and write this is no problem, really. You can do this with a very small model. But if you're tackling legal texts, where what is written in the first paragraph is kind of modified by the third paragraph, and then in the sixth paragraph there is a complex question, and you need to have all of those kind of observations in relationship, then you need a bigger model just to be able to model that distribution. And so now you could say, okay, well, I'll just grab one of those awesome open source models and I'll fine-tune it so it learns my challenge. It learns my data, it learns to solve my problem. And I'm sure you or your customers or your partners have given this a try, and everyone I've spoken with that have tried this, they came out of it somewhat underwhelmed, somewhat frustrated, right? You can fine-tune a model by shifting its behavior a little bit, but if you really want to teach something new to the model, it's very difficult, and you could even say it's impossible. So one of the things we've been building at Aleph Alpha is an LLM architecture that doesn't use a tokenizer anymore. And a tokenizer is basically what's breaking down texts with a limited vocabulary. Again, I'm not going to go too nerdy into that. You can look up our paper about this. But the tokenizer fundamentally limits the knowledge an LLM can learn. And we've introduced an architecture that doesn't need a tokenizer anymore. And we've shown, and this was first shown in Davos about a year ago, together with AMD, that, and this is a funny example where we basically had two models that were trained on English only, with similar size, like identical data and identical training iterations, and then we tried to teach Finnish to these models. That's a Finnish language, very different from English. And we looked at the comparisons. We compared against Apple DCLM, plainly because it's a phenomenal baseline, because it's so open. And now you see that when you look at the grammar and spelling on the very left, both models are somewhat good. But when you look at their quality of following instructions or the quality of their results, there's a huge difference when you extend the knowledge in a tokenizer-free way. And in addition to that, you're also saving a lot on efficiency, because every new token scales with your compute need, right? So in an autoregressive transformer, every token gives you basically a linear scale on your complexity, on your compute. And what you see here is we kind of normalized on the Llama on H100, on NVIDIA H100. This is 100%. And then we looked at different models and different languages. And at the very bottom, you'll see a specialized model for Nordic languages built by Silo AI. And of course, this is more efficient in Finnish, right? This is the yellow bar. It's like 160% more efficient because it has a tokenizer that's optimized for Nordic languages. Makes perfect sense. But then if you then look at our T3 models, those are not specialized on any language or any data at all. They're completely tokenizer free. You see that for a complex outer distribution language like Finnish, we can go up to 350% if we optimize on MI300X. And this directly impacts your cost, your hardware footprint, and your latency, your speed, right? And so if you are using an open source model that has been optimized on English, and you're using that for either English text that's really specific, or even other languages like French or German or Italian, your efficiency goes down significantly. And this can make a use case that would make economic sense, makes no economic sense anymore. All right, so what does Deutsche Bank think about it? Bernd, to you.
Yeah, Jonas, thanks for being on stage with you today, and welcome everybody. So, first of all, I want to share that we have a partnership. We are conquering together new grounds In the past, we would have called it innovation. Today, we call it transformation. But what stays is, and that is the logo on the page. For those who do not know the logo of Deutsche Bank, it's a slash that's going up, which means it stands for growth, but it's in a complex, but as well controlled and secure environment. Why is this important? It's back to the topic of trust. Trust is the ultimate currency we have received for free from our customers. And despite all the hype, we will not give up on trust, as if we lose that currency, which we have gained over more than 150 years. You all know the famous speech that trust has to be earned over years or decades, but it can be gone within seconds. And why are we doing this? We are, first of all, fully embracing and embarking on AI. On agentic AI, on agents, and we just shared this with the capital market last week when we have our investor deep dive in London. A big part of our future growth in terms of profitability, measured in the bank as cost-income ratio, as well the return on the tangible equity, is built on the application of AI across the entire franchise. Now the but comes, but this does not happen without controls, because that logo that was built 50 years ago is still valid, and we reconfirmed that as part of our culture, that we are dedicated to our clients' lasting success. Now the difference, as a global house bank, we do this at home, in the home country, you could call it Germany or Europe, but as well abroad in a geopolitical environment that's getting more and more relevant. But as well, we are dedicated not just to success, as well to their financial security and stability. And why do I say this? When you then look at how we embrace that large language model, how we embrace AI, we started with mobilizing the troops, mobilizing our workforce. And that is nothing else as an augmentation of our human beings' capability. We built digital assistants. I would not call this a transformation. It's just an augmentation, and I would say an efficiency gain. We extended that in the next phase by saying we want to automate existing processes. But it is not, when you talk about automation, it's not transformation, it's not redefining an existing process. It's and somebody asked me in our board, Jonas, how would you describe this to a non-tech person? And I said, okay, a good question. It's like on mobility. If you want to go from Charles de Gaulle Airport to that beautiful building here, if you only focus on automation and speed, you might buy the fastest car in the past. In the meantime, you use GPS to find a smarter way to come from Charles de Gaulle to that beautiful building. So, and that is now the amplification, it's the third phase. And I give you a concrete example and then the application of trust. If customers, whether it's a private customer or whether it's a corporate customer, are asking for a credit, we have already models in place. So what was mentioned with large language models to steer and control our business is not new for a bank. We are modeling credit risk, we are modeling market risk, and based on that, we give a positive or negative answer, but as well have terms and conditions, including the interest rate we offer to customers. And we want to automate that whole process and have this kind of a straight-through automated process that agents take over that credit risk approval. But we will as well build agents that are controlling and monitoring the decision. So it's a two-way street, while I would say the primary agents are trained and are learning from the human beings' behavior of the past. Now the new agents are as well monitoring and controlling these agents, and that is kind of the trust we need. So we need transparency, we need explainability, and therefore the ethical behavior of us as a bank, as a financial institution towards our customers and the market. How are we doing this? We have built an AI oversight forum where all the control owners from GDPR, from security, from compliance, from financial crime, money laundering, you know all those, are present. And kind of these new models need to pass these thresholds in order to stick to what the logo is promising. And Jonas, I think we have built together a cool innovation case in a short video.
Indeed.
And with that, I would hand over you to show that how it works in practice.
Oh, I'm excited to show this. And maybe one sentence for our co-innovation partnership. You may remember the old then Facebook slogan, move fast and break things, right? This is not how you want your bank to behave, right? This is maybe fine for your social network, but your bank relationship demands impeccable reliability. And I think it speaks to Bernd and his team that of all our partners, Deutsche Bank is one of the most innovative partners that still never compromises on trust. And yeah, we have a video. So first of all, agentic capabilities, right? I mean, it's like a bunch of list of agentic capabilities. In this case, it's an event-driven architecture. So we are monitoring events, in this case, capital markets events, could be anything, could be credit risk events. And then we're triggering an agent based on events, right, that are coming in. Pretty standard stuff, you might say, right? But what Bernd says basically comes into play in the next video is that we are monitoring this, or Deutsche Bank is, right? We are taking control of everything and making sure with like independent checks, triggered like on-demand human involvement, different AI systems, that there's never any costly mistake. And the customers and the partners of Deutsche Bank can always trust that they move fast, but never break things, right? So I think that's quite remarkable, and I think it's precisely what I would want my banking partner to do. And when you think about what this means for human-machine collaboration, right? I believe that responsibility can never be delegated 100% to AI systems. And humans will always remain incredibly necessary. But we will have, in the future, we will have enterprises that are running hundreds of thousands of agents asynchronously under the hood. And of course, humans in those patterns, they cannot look at every agentic output and do thumbs up, thumbs down. You have to have smart interconnected systems that interact with the human in a smart way, right? And I think this is precisely what Deutsche Bank is building with like AI governance and AI safety and trust framework, which is quite remarkable, which I haven't seen with any of our other partners quite as mature and sophisticated.
And Jonas, let me add, so in the previous world, our credit risk managers had to rely on information which we had in-house. Now with these large language models, they can access as well information about companies, about individuals that are present in the World Wide Web. And that is step one, but then it must be a credible source and not a kind of a source that was established to manipulate the credit risk decision. So, and here this, I would say, one agent collecting and kind of summarizing, augmenting a human capability, but a second agent challenging and do the transparency, plausibility, and control check.
That's quite remarkable. And there's a nice quote I found that fits, I think, the future paradigm really well. And this is one machine can do the work of 50 ordinary men. No machine can do the work of one extraordinary man. And I think it's our responsibility to make sure that we enable all humans into the role of extraordinary like men and contributors, right? All the stuff that is super standard and AI can do, we need AI to do it. But the human contribution will always be paramount towards a trustworthy and safe application of AI. Thanks.
Thank you.